In this episode, we discuss the industry standards for industrial IoT. We discuss the importance of standardization for IIoT, the phases of a standard lifecycle, standards engagement strategy for IIoT vendors and end users, and how to identify potential areas of standardization in an IIoT stack. My guest on this episode is Claude Baudoin. Claude has over 46 years experience in managing software engineering departments, IT departments, and advanced technology groups in France and the United States. He is the owner and principal consultant of cébé, an IT and knowledge management company. He is the co-chair of the BMI task force and energy domain expert at the Object Management Group and Industrial Internet Consortium. He is also a senior consultant at the Qatar Consortium. His undergraduate degree is from École Polytechnique in Paris, and he holds an MS in computer science from Stanford University. He has published 2 books on software engineering, which are Programming Methods and Realizing the Object-Oriented Lifecycle. He's also published numerous papers and conference presentations, one of which is the Global Industry Standards for IIoT, and he holds 2 patents related to IT infrastructure and security. Quick thank you to our sponsors. This episode is made possible by HiveMQ, providers of an enterprise-grade edge and cloud-based MQTT broker, and Octo22, manufacturers of reliable industrial controllers for automation and IIoT applications. Welcome to the 4th generation podcast here on Industry40.tv, which is a series of weekly interviews designed to help you learn IIoT from some of the world's leading practitioners. So make sure to subscribe and click on the notification bell to make sure that you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcasts, follow on Spotify, and connect with me on LinkedIn at Kudzai Manditereza. Now, here's my conversation with Claude. Okay, Claude, thank you so much for joining us today. I would like to welcome you to the show.
Thank you. It's a pleasure to be here, ready to answer your questions.
Absolutely. So today, I really want to talk to you about the industry standards for IIoT. So maybe you can begin by explaining to us why standardization is important for IIoT.
So, great question, and it's usually something that people have some trouble articulating. I just co-authored with a couple of my colleagues a paper on standardization strategies for companies that use IIoT, as well, of course, as developers of IIoT capabilities. And I think one of the key motivations for people to adopt standards or even to help develop standards is that in an IoT application or system, you have a whole stack, a whole layered architecture with different levels that go from your proprietary application, where if you're a vendor of IoT capabilities, you have intellectual property and you have some innovations that you've implemented. And then you've got frameworks and middleware and communication layers. And then at the bottom, you have the sensors and the hardware. And you don't want to have to reinvent the entire stack. You want to focus on the top level where you've put in your IP into developing a unique system that provides capabilities that no one else has. But below that, you want to basically be able to buy the building blocks on the market. And in order to be able to integrate all this together, you need to have standards, because you don't want to reinvent your own communication protocols, your own hardware, your own middleware, your own database structures, etc. You're obviously going to get commercial products for that, or you're going to use open source. So using standards allows you to eliminate a whole level of recreation of part of the technology stack you're using in your IoT solution.
Oh, okay, that's interesting. Okay, so as you have just explained, standards play a key role in IIoT solutions development, but a large number of professionals and organizations, they don't really know how a technology becomes a standard. So could you take us through the phases of a standard life cycle from the conception of the idea?
Yeah, it depends a little bit it's hard to say that there is a standard for standards, right? It depends a little bit on which organization is spearheading the effort to create the standards. So you have multiple types of organizations that develop standards. And so one type of life cycle is when a company has developed a technology that is becoming widely adopted across the board by others. And it sort of becomes a standard just by virtue of this organic adoption. And at one point, people decide, okay, now that this is generally adopted by not everyone, but by a large segment of the industry, let's turn it over to a foundation or a nonprofit or another organization so that it's no longer being identified as being a particular company property, because that could limit adoption, in particular by, of course, that company's competitors. So that's one process is something that we would call a de facto standard, something that is just, you sort of call it a standard between quotes because you know that everyone is using it, but at some point the company that invented it says, all right, let's turn it over to someone who can make it a more neutral product. Then you have the complete opposite, which is what is being done in the International Organization for Standardization, ISO, which is that someone proposes a project to develop a standard. It's either a country organization or it's a company in some organizations, and then you go through a process of committees developing successive standards, and you go through a voting process until it's adopted and published. So that's how ISO works. Somewhere in the middle of these two extremes, you have organizations like maybe the IEEE or the Object Management Group, with which I consult for them. So I'm helping them with their standards roadmap, where it's more of an industry consortium. People are meeting together without all the administrative complications necessarily of a group like ISO, but we have a process to ask people to make submissions and sort of combine those submissions, discuss them, etc., until we can get adoption. And that process has the merit of taking less time than the ISO process. An ISO life cycle is typically 6, 7, or 8 years. An industry consortium usually produces a standard in 2 to 3 years.
Okay. So now for industrial IoT vendors that want to adopt these standards, what would you say is the best strategy for engaging with these standards? And also, as a follow-up to that question, what would be the best strategy for engaging with the standards if you're coming from an end user point of view?
Excellent. It's such an excellent question that actually, when we drafted the paper, the standards strategy paper at the Industrial Internet Consortium recently, one of the questions that came back from one of the researchers in Germany about our initial draft was that we had not clearly delineated the difference between adoption by a vendor and adoption by an end user. So that shows how relevant your question is. So the first thing is a company, whether they are a supplier or an end user, actually, they have to determine where is the intellectual property they want to protect, and where are the areas in their product architecture where it is not important to have their own unique intellectual property, but it's a better strategy to adopt what exists outside and rely on standards. So you want to be very careful about where are you unique, and you're trying and you want it to be your own thing, protected by copyrights or trade secret or patent, and what are the parts where you don't have any intellectual investment, so to speak, and you're going to use the standards. Once you've done that, you need to determine what is your level of engagement. So one thing I certainly wouldn't recommend is not having any sort of engagement, because then you're at the mercy of what other people do. So if a committee somewhere is deciding suddenly to produce version 2 of a standard, and your customers say, hey, why are you still on version 1? Everyone else is using version 2. Now you are at a competitive disadvantage, and that comes as a surprise if you had absolutely no effort to even maintain awareness of the life cycle of that standard. So at minimum, you have to do some standards watching. You've got to look at, you've got to basically have a portfolio of what are the dependencies that your products and services have on which standard. So you will say, okay, I have this product and this product and that product, and we're talking about IIoT. So are they using OPC UA as a data exchange mechanism, or are they using the data distribution service, DDS? Are they using MQTT, etc.? So once you know these dependencies, you're like, okay, my products rely on OPC UA. I've got to watch what the OPC Foundation is doing, what they have cooking for the next version, what are the additions they're planning to make to their standard, in order to be ready to decide whether I should adopt those and include them in my product or not. So that's the minimum level of engagement that is recommended. Now, if you have a stake in guiding the evolution of the standard, so if your dependency and your the level of importance of that standard in your product is such that you really don't want to let it go in whatever direction others decide, then you may want to put more skin in the game, get involved in the committees, and at least attend the committee meetings and potentially do some real work. So you have to put sweat equity into this in order to help guide the standard. And frankly, most companies are, of course, reluctant to put in the resources to participate actively. So if you do, you get a lot of influence. So you have a lot of possibility of actually, I wouldn't say controlling, but influencing and discussing with others how the standard should evolve. And then you have the benefit of knowing a year or two in advance where the standard is going to go, and you can tell your R&D team, this is where the standard is going to go. Be prepared to integrate this evolution into the product architecture.
Oh, okay. All right. Yeah, that makes a lot of sense there. So now, one thing about an industrial IoT solution is that it contains many layers. So how would one go about identifying those potential areas for standardization?
So there's a fundamental document called the Industrial Internet Reference Architecture, IIRA. It was published by the Industrial Internet Consortium maybe 7 or 8 years ago, the first time, and it's gone through several versions. Can't remember the version number right now, but if you Google Industrial Internet Reference Architecture, you will find the document. It is public, it is free, and it gives you all the layers of the architecture. The function, the sensor, edge computing, communication, integration with enterprise applications, data analytics, and machine learning. So it describes that, and that's going to give you a nomenclature or a taxonomy of all the areas where there can be standards. And in the paper I mentioned also from the Industrial Internet Consortium called Strategy for Standards. I think it's called Global Strategy for Standardization, something like that. It also contains tables of the areas of standardization you should consider, such as communication protocols, such as data storage, such as edge computing, etc. So those classifications of the type of standards on which you may want to rely are in those papers.
Oh, okay. So now, bearing in mind that the industrial sector is a bit conservative when it comes to the use of open standards, what is the best way of adapting open standards to an industrial architecture?
So I mean, not all sectors are that conservative, but I think in general you have a good point. I would say I've seen a lot of large manufacturing enterprises. I don't want to name names because I don't want to privilege some people or shame the others, but I've seen some major manufacturing companies be very aggressive in trying out various standards. For instance, Li-Fi for light fidelity, which is a way to transmit data in a room through visible light, as opposed to using Bluetooth or Wi-Fi. I've seen certain, adoptions of, again, communication protocols or AI and image classification standards, etc. So not everyone is lagging behind, but I think the problem, as usual, is to make a business case in the company. So you usually have some people who are very aware of why it would be important to participate, to adopt standards and potentially to participate in their development. And then you have business people who are going to ask you, why should we devote effort to doing that? What's in it for us? And you have to be able to articulate that business case in order to win that discussion. And these are the kind of activities that are always threatened in a company, because as soon as someone wants to cut costs, they're going to say, oh, why are we paying for your travel to go to these standards committee meetings? Can we cut this? What has been the benefit to us? How much more money are we making because we're using standards? And so you have to justify either the additional revenue you're making or the costs you've eliminated by using some standard building blocks for your products. It all comes to the business justification, and there's not a general template for that. The paper I was mentioning gives people some ideas about what those justifications could be, but you have to look at the specifics of your industry domain and the architecture of your own product portfolio and articulate the dependencies of the products on the standards in order to justify why you need to be involved in the standards.
Oh, okay. All right, that's interesting. Okay, so you've already mentioned a few connectivity technologies there. Now, seeing that connectivity plays a crucial part in building IoT solutions, can you tell us about IoT connectivity standards that are currently available on the market?
Well, this has been evolving towards standards that provide more semantics content. So where it's not just the format of the data that is standardized, but it's also the metadata and the semantics of the data. And they've also been evolving to provide more security. And so you've got, originally you've got things like MQTT, which was prevalent, but is relatively limited in its functionality and its security. Then you have the OPC Foundation's OPC UA, which has a long history of coming from Microsoft technology, which there was OLE for process control, which became the OPC standard, which was extended to become the OPC unified architecture, and then was given to the OPC Foundation according to the process I described earlier, where Microsoft said, we really want to make this something that's adopted more broadly than by Microsoft users. Therefore, we're going to de-Microsoftize it and pass it on to an independent foundation. And then one of the relatively recent entrants, even though by now it's I think a 17-year-old standard, is called DDS. It's Data Distribution Service. There are about four major providers, well, four really major ones, but there's probably a dozen competing providers of software that implements that protocol. And the advantage of DDS is that it is from the get-go a publish and subscribe standard. So it is possible to dynamically add a new listener to the network and say, I'm subscribing to this and this and that data channel. It has quality of service parameters. So when you define that when a new system is plugged into the network and you configure it to receive, let's say, temperature data from certain sensors, you can say, I only need a temperature point every second. I don't need every temperature point that's generated, even if they're generated faster than that. And then the broker on the network, which adapts, if you wish, the listeners to the subsystems that are sending data to the network, filters all that traffic, and only delivers to the listeners what they've decided to subscribe to, which can be, I only want a data point every second, or it can be only send me the temperature if it exceeds 105 degrees, something like that. So that frees the clients the listeners or the subscribers. It frees them from a lot of the logic of receiving tons of data and having to filter it out. That is done by the service. And the other thing that DDS does is it has a very extensive security layer. It has added an extension called DDS Security, which is extremely powerful. And there have been many demonstrations done in public, in meetings, and in conferences of interoperability between implementations of DDS from several vendors. So companies like Twin Oaks Computing and AD-Link and Real-Time Innovations, which are sort of the three initial founders of this standard. You can buy a product that includes the DDS implementation from one of them, and you can connect it on the same network with a product that includes the DDS stack from another vendor, and they will talk to each other.
Oh, okay, that's interesting. Now, it goes without saying that security is a key part of IIoT. Are there any standards that are related to industrial IoT security?
There's no, to my knowledge, there's not really specific standards except DDS security I just mentioned. The challenge in IIoT has been that we know that in general, using public key infrastructure, PKI, would solve a number of problems about the mutual authentication between an IoT device and the control system that is talking to it. And it would also make the information confidential in transit between those two entities. So that would solve a lot of problems. That would prevent man-in-the-middle attacks. That would prevent a sensor from receiving a command from a non-authorized user and executing it. It would also prevent the insertion of a fake sensor in the network to send bad data on purpose to a control system in order to make it take bad actions. The problem is that implementing PKI at the device end can be difficult because you need a certain amount of storage and compute power to execute the encryption and decryption and store the private key in a secure manner. So if you don't have a hardware secure module, an HSM, at the device end, that becomes a problem. And people sometimes are solving that by putting a gateway close to the device or close to a group of devices. That gateway has the power to run PKI, and then it's only not even the last mile, but maybe the last meters of communication between that gateway and the sensors and actuators, which is not protected by PKI because the devices can't run it. So these are some of the challenges in implementing security at that level. And again, in most cases, a PKI would do the trick if you can define an architecture where you have an endpoint that is PKI capable.
Oh, okay, that's interesting. All right, so now seeing that we've got like many standards that are popping up. I mean, for example, we've got the connectivity standards. How do we avoid building new silos whereby systems can't share information even with standardization in place? And maybe as a, just to follow up on that question also, what do you see as being the biggest barriers to agreeing on standards then?
Well, I mean, there's obviously corporate interests. You know, you have vendors who have made a certain investment into developing a technology before a standard existed, and they're going to be reluctant to abandon that and redesign their product in order to fit with a standard. So people should always ask a vendor, I mean, an end user should always ask a supplier, what standards are you complying with, and what interoperability gateways or interoperability capabilities do you have with other standards? And in some cases, there are public interoperability gateways. So for instance, I mentioned earlier OPC UA and DDS. Well, there is a standard for the interaction between those two. It was developed by the object management group about, I think, 3 years ago now. So the OPC UA DDS gateway exists, and there are several vendors that implement it. So if you know that, then it means, okay, I can have a vendor that speaks OPC UA, another vendor that speaks DDS, and if I implement the gateway between the two, I can mix and match the two protocols. That's the kind of questions you need to ask.
Oh, okay. All right. So another thing is that ultimately organizations are going to be faced with the task of having to choose between building IIoT solutions from scratch or buying off-the-shelf IoT solutions. What's your recommendation as far as that is concerned?
I think it's a matter of really working with the R&D group that makes the products if you're a supplier, and clearly deciding what are the levels of the architecture, what are the places in the architecture of your product where you want to be unique because that's going to be your selling point, versus the places where you want to save cost by being able to reuse what already exists and not redevelop it. So once you can essentially take your architecture diagram for your product and take some colored crayons and say, this is the green part and this is the red part, or whatever color you want to use, meaning these are the parts where we want to focus our creativity, and this is the part where we want to reuse commercial off-the-shelf components. Then, you know, you take the example of SCADA versus IoT. In SCADA systems, you had proprietary hardware very often, or you had PLCs with very specific code in them. Today, an IoT system is going to run on Linux or Windows. It's not going to run on a proprietary PLC. It's going to be running a standard commercial operating system. Maybe it's a real-time operating system, but it's still going to be one that is commercially available or that is open source. So we need to do make the same arbitrations at every level of the architecture. It's not just that we've moved from PLCs with their sort of arcane non-standard code to standard operating systems, but we've also moved to using communication protocols that are layered on top of TCP/IP or UDP. So we're no longer using proprietary lower levels of communication. etc. So as time goes by, that boundary between the proprietary capabilities and the standard platforms, that boundary is progressively going up. And we're using more and more standard components for the bottom layers of the architecture. But that's a conscious decision that a product team needs to make.
Oh, okay, that makes a lot of sense. Now, as we wind down, what I would like to find out is, you've touched a bit on that. What is the role of the Industrial Internet Consortium in the Industrial IoT Standardization?
So the consortium is basically a place where a number of companies, I think there's 300 members or something like that, come together to help define the best practices for IIoT development, deployment, and use. So it has quite a number of working groups that talk about, there's a group about standards, there's a group about vocabulary and taxonomy and definitions, basically, of the various concepts. There's a group on distributed computing. There's a group on the use of blockchain in IoT systems, etc. So these are opportunities to network with other companies, opportunities to know what the marketplace does, to form alliances potentially. There's two key activities which are called test beds and test drives. So a test bed is a very elaborate, fairly complex, usually, implementation of an IoT platform done collaboratively by 3 or 4 or 5 companies that each bring one piece of the system, and they construct that prototype and demonstrate it to other people, and then they can take it to market if they wish to do so. Usually the partners will include maybe a sensor company, a software company, an AI company, and an end user. And for instance, the first testbed that was done years ago already was about tracking and tracing tools in a factory. So how to not use, not lose, not misplace, and not use in the wrong place electric screwdrivers, for instance, in a plant that screwed on the surfaces of an airplane wing. That was the specific case. So you demonstrate that, and then the partners in that testbed can decide to make it commercial if they want to. There's a simpler, lower level, if you wish, type of activity called test drives. In a test drive, it's basically one company or group of companies are offering a particular implementation and is allowing the other members of the consortium to come and test it for their own usage. In a sense, it's like test driving a car. You take it out of the showroom, you drive it for half an hour, and you decide whether it's good for you or not. So test beds, test drives, and then these various committee meetings that talk about those special topics like security. There's a group on trustworthiness. I already mentioned, blockchain and distributed communication, edge computing, etc. And there's a big member meeting every quarter. It actually happened just last week, and it was virtual. The next one, hopefully, will be in person again, where people exchange.
Oh, okay, that's interesting. All right, so lastly, you are the owner and principal consultant of a company called cébé. I hope I'm pronouncing it correctly. cébé IT and knowledge management.
Yeah, it's cébé IT and knowledge management, yes.
Okay, yeah, sure. So can you please tell us a bit more about your company and what services do you offer?
So it's a small consultancy that was founded 12 years ago, based in California now. It's we work on IT strategy mostly. So we help people define their enterprise architecture and their IT roadmap on the basis of a model of their enterprise, of their business capabilities, of their business processes, and how to align the IT portfolio and the IT projects with the business processes and the capabilities of the enterprise. So that's one of the main activities. It's enterprise architecture based, and often a big component is the analysis and improvement of business processes. The other facet of the company is knowledge management, as the name indicates, cébé, IT, and knowledge management. And that has to do with providing guidance on classifying, retaining, reusing the knowledge that's normally locked in the heads of the employees, and in particular, proposing how to organize communities of interest or communities of practice so that people can share their knowledge with each other and make that a knowledge asset of the enterprise instead of being siloed into the heads of the people.
Oh, okay, that's interesting. Okay, with that, we come to the end of our discussion. Thank you so much for taking time to come out and join us on the show.
Thank you, Kudzai. It was a pleasure talking to you.